All right, so let's say you're given this integral here, and the question wants you to compute the integral. To start, the core idea needed to solve this question is called U substitution. When given an integral of the form below, where g of x is a function, and f of g of x is a function that has the g of x function as its input, so f of x, g of x is inside of the f of x. To apply u sub, we can let u equal g of x. If we take the derivative with respect to u, we get g prime of x dx. Sorry, there's a bit of a typo here. There's no prime on that g of x, but there should be. Sorry about that. So the goal of the u substitution is to find the g of x expression, let u equal this function g of x. And then looking at this integral, we can plug in u for g of x and du for d of x. If we do that, it simplifies the integral to a form where it just depends on u, no longer on d of x. When we use this u sub, it makes the integral much easier to compute. We can apply this to our example. To apply the u sub, we must identify the integral following this form here. It just means we need to look at the dependence on the x variable and figure out value for g of x such that when we plug in u, we get rid of all the x dependence. If we look at inside the fraction, we can notice that we have this x squared plus 1. And if we take the derivative of x squared plus 1, we get 2 of x, which is the value at the top. This means that g of x is equal to x squared plus 1 in this example. This can be better seen when we transform how the integral looks. This is how it looks right now. And if we compare it, if g of x equals x squared plus 1, this means that f of x is equal to 1 over x. Since we know f of x is equal to f of g of x, if we plug in g of x equal to x squared plus 1, we get 1 over x squared plus 1, which is the correct form of our original integral. That's how we know that we're on the right track here. This part is less important. We just need to identify what g of x is and try to plug it in and hope that when we plug it in, we get rid of all the x dependence in the integral. So now that we know g of x, we can let u equal to g of x. And then if we do the derivative of u, we get g prime of x dx. And we know that g prime of x is the derivative with respect to x, and that's just equal to 2x. So we get this expression here for du. We can also plug in u equal to x squared plus 1 into the integral. If we notice, this 2x dx can be replaced directly with du, and then the x squared plus 1 in the denominator can be replaced directly with u from our definition. And so now the integral we have here is much simpler to solve. And the integral of 1 over u is just equal to the natural logarithm u. We plug in our value for u with respect to x because the original integral is with respect to x. So if we plug in u equal to x squared plus 1, we get this for the final answer. This represents the integral of the original function here.